Let's discuss the another phenomena of phase transformation, that is from liquid phase to vapor phase. The phenomena which we call vaporization. The phenomena of transformation of liquid to vapor is termed as vaporization, and we can state that vaporization of a liquid takes place in two ways, and we can also write the two phenomena of vaporization takes place simultaneously. The first one is evaporation, which takes place at all temperatures. The second one is boiling, which only takes place at temperature equal to boiling point. When the liquid temperature becomes equal to boiling point, then only boiling takes place, whereas evaporation takes place at all temperatures. Let's discuss the two phenomena step by step very carefully, because both are quite important, as these two takes place simultaneously when temperature becomes equal to boiling point. Say if we consider a container in which, say, we take some liquid, or we can also take the example of water in case of just primarily understanding. We can state all particles of water, due to thermal agitation, they are in random vibration and they collide with the neighboring particles continuously. And due to continuous collisions with the neighboring particles, each particle exchanges energy between the neighboring particles. Now in this situation, those particles which are there on the surface of the liquid, they gain energy due to collisions by the particles below the surface. Obviously, some particles gain energy and some particles lose energy, because the overall energy of the system will remain conserved. Now, in this situation, some particles which will gain some extra energy will jump off from the surface of liquid, but due to atmospheric pressure, obviously as the atmosphere is exerting a pressure on every physical substance placed beneath it, we can state due to atmospheric pressure, most of these particles will fall back to the liquid surface. But due to continuous jumping and falling back of these particles within the liquid surface, we can state a thin layer of particles is developed just above the liquid surface, and in this layer we can state the particles are not in liquid phase, these are relatively free, or you can say these are free from the liquid phase. So this we can state there is a thin layer of vapor, as these particles are escaped from the liquid surface. So a thin layer of vapor is formed. The layer is formed because of atmospheric pressure. And in this vapor, the pressure which the particles are exerting on atmosphere is called PVP. It is denoted by PVP, and this PVP is called vapor pressure of liquid surface. And obviously in this situation, this vapor pressure is less than atmospheric pressure. That's why these particles are not able to escape. But still, within this layer of vapor also, when the particles collide with each other, there are very few particles during collision, they gain some extra energy and overcome atmospheric pressure and escape from the layer also. There are very few particles. These particles which are escaped are called evaporated particles, and the phenomena under which these particles are escaping from the liquid surface is called evaporation. So we can state evaporation is taking place at all temperature, and if we increase the temperature of liquid, certainly the thermal agitation will increase and number of particles which are escaping from the liquid surface will also increase. So we can state as temperature increases, a rate of evaporation also increase. So the number of particles which are escaping from the liquid to atmosphere, certainly these number of particles will also increase if we increase the temperature. And as you increase the temperature, vapor pressure of this liquid vapor also increase, and the thickness will also slightly increase as the vapor pressure which the particles are exerting on atmosphere will also increase. And we can state at temperature T is equals to TB, which we call boiling point. This is the temperature at which we can state the vapor pressure of liquid becomes equal to atmospheric pressure, and as soon as the vapor pressure becomes equal to atmospheric pressure, all the molecules of liquid which are there in this thin layer of vapor will start escaping to the atmosphere, because the vapor pressure is able to overcome now the atmospheric pressure. So now onward we can state the rate of evaporation as maximum. Every particle which is escaping from the liquid will escape to atmosphere. This phenomena we call boiling. And before boiling we can state at all temperatures the phenomena of evaporation is taking place, and at the boiling point, when boiling starts, all particles which are escaping won't fall back to the liquid surface. They'll overcome the atmospheric pressure and escape into atmosphere. In the concept of vaporization, one important term is latent heat of vaporization. This is defined in a similar way in which we have defined the latent heat of fusion. We can simply state that this is the amount of heat required to vaporize a liquid of unit mass. It is denoted by the symbol LV. Like latent heat of fusion was denoted by LF. Its unit also we can write as joule per kilogram or calorie per gram, etc. And simply we can define that the heat required to vaporize a liquid of mass M is the amount of heat required can be written as MLV. As LV is the amount of heat required to vaporize a liquid of unit mass, so for a mass M of liquid, the total amount of heat required can be written as MLV. We are going to use this relation in various numerical problems now.